Okay, Mr. Customer, now that we've finished the inspection, what I'd like to do next is just kind of review a little bit about what's been going on. We'll talk a little bit about just, the earth, what your house is sitting on and how that affects what's going on with your house. And then some possible solutions to rectify and prevent it from ever happening again. So I want to start by showing you this quick graphic here, this video that's going to explain what the potential issues are that are going on. We can discuss that. So first, it's important to know the different layers, right? There's glacial deposits, and then there's been wind and all kinds of weather that has affected the earth and what would be sitting underneath your house. And then, of course, we come in and we put in fill soil because it's an imperfect surface. We've tried to create a surface that's worth building on. And so you can see we've created different layers over time and by man-made layers, right? From organic matter all the way down to basic parent rock or bedrock, right? The supportive. So when we build the house, we dig out, right, into the unsettled earth. And then we put in the footing for the foundation. Once that's cured, then we build the foundation walls. On top of that, we start putting in the floor framing system. You'll see that going in now. The subfloor, and then put on this big, massive, heavy house on top of it, right? And so it's important to know that what you're sitting on is not bedrock and it's not stable. And we've created a situation too when we've built the house. First, you'll see where we backfilled over here with loose soil, right? And so Mother Nature, like native soil, had an effect on it to make it firm, right? And so you can see here where we're sitting on down here is the bedrock I mentioned before. Anything above that up to your house is what we call an active zone. And so that's materials that are subject to moving, right? And so we'll move on in a second here. And so now you can see where a house is sitting on a foundation. Foundation is exposed over here and sitting the active zone. And what you'll see is somewhat common is uniform settlement. So you can see the house is evenly settling, right? We don't get a lot of calls on that because it's usually not very obvious that it's happening because you don't see any signs, any indicators. There's also tipping settlement where just one portion of the house, the front or the back or something like that, is tipping forward. Again, we don't always get calls on that. It depends on how much it tipped, right? But it's still important to address. Differential settlement, that's what you're experiencing in your house, where there's just different areas where the unsettled earth below is giving away and causing problems. And we'll see evidence of that by things like cracks in bricks, cracks in the walls, and sloping floors, right? And so we've seen some of that evidence here too, right? How does this happen? Well, the dry season is a big culprit. You can see in the loose fill over here, it dries up and shrinks, creating big gaps. And it's not supporting that foundation anymore, and it starts to sink because of lack of support, right? And so in the wet season, we may have dried out that soil, but now we're going to wet it, and there's a lot of channels for that water to go through. Water's always going to go to this loose fill area anyway, and you can see the pressure building, and then you're going to start to see, as the pressure is high enough, it's going to start going underneath the footing of the foundation, creating a washout, and that's a huge culprit for that sinking and settling, right? That causes landslides, houses to sink, and getting your truck stuck in the mud too, right? And so one we don't always think about, poorly compacted fill soil. There's a strict protocol in backfilling a foundation like that, and nobody usually, or hardly ever, uses that protocol where you got to compact it in layers, so it's still loose, and that's a big problem. So any questions about that? And do you think that there's any of those three that are the biggest culprit? I know you've been living here a long time. Okay, you can see the different kinds of settling here that we've seen, uneven tilting. All right. Let's move on then. Just to kind of recap, there's natural soil layers and then there's man-moved ones, right? And we're sitting on a man-moved one, and we're always sitting on active soil. There's no way around it. We don't build on bedrock, we build on soil that's active. Soil's always moving, right? And so, again, there's three different soil types: the backfill, the native, and then still you're sitting entirely, that slab is on man-moved soil. And so, of course, the dry season, we talked about that real quick, where it dries out and shrinks and the foundation can sink over there. We have over here wetting and softening soil. And here's a good graphic of how much water typically, if it's not setting, if we didn't have backfill properly, then a lot of water can come in there and cause problems. And then, of course, the poor compaction, right? So, what I want to do next is just talk about different options that you would normally have. There's a few that I refer to as kind of historic options where contractors in the past have tried, but they really aren't like a permanent or the proper solution in my mind. But let's talk about what those are. You may have heard of them before or encountered them, but concrete piers and steel concentric piers. Those are just basically tubes made out of concrete or concrete wrapped in steel. And they try as hard as they can to drive them down into the earth, right? They're driving them down into that unsettled earth, but they just can't drive them far enough to hit bedrock where it's solid that will support your house. So you're really not addressing the problem. You're adding some additional support, but those supports, they have a tendency to break when they're driven in. You can't drive in a tube of concrete into the ground very far. And so it's really not considered a permanent solution and really not widely used, if at all, anymore, right? And so another thing that people have tried in the past is concrete underpinning. You see that we dig out around the foundation. The idea is that if you have, like a lot of people say, do you walk in snow with your regular shoes or snowshoes, right? If you're walking in regular shoes, you'll sink into the snow. It's easier walking snowshoes because there's more surface area to keep you up. And so that's the idea, is that people would have thought maybe just if the footing was wider, then there would be more support, less of a chance of it being able to sink into the earth. Well, what they do is after they've dug out underneath the foundation and supported it here so they can put in a bigger footing, they pump in thousands of pounds of concrete and then backfill it again. And what they've done really is they've taken your house, which was too heavy to be supported by the soil below, and they've made it thousands of pounds heavier. So what do you think would happen then? Well, we've learned from trying it that it just makes the house sink faster and more. It's not a permanent solution because they didn't address the problem. They actually created a bigger problem. The real problem is what the house is sitting on, and that's the soil, right? And so then, of course, some people might think, you know what, let's just tear out the foundation and start over. A new foundation is better than what we have now. And I can tell you that it's really not. And so it's very expensive. It's about $60,000 per wall. It takes a very long time to do. After they've removed all the walls and jacked up your house, you have to vacate, obviously. You're not living in the house during this process. They've detached all the utilities and torn down your deck out back so they have access to the entire foundation to remove it, right? And once they've done that, then they can pour footing. The footing then has to cure before they can pour a foundation wall. At least they better do it that way or they've caused a big problem, right? It takes about 28 to 30 days for that to cure. Now they can pour new foundation walls, another 28 to 30 days. So now you're at least 60 days into the process where they can put the house back down, then have pay somebody else to come back and reconnect all the utilities and backfill. And so you're into it for having been out of the house for a very long time, spent quite a bit of money, and you still haven't addressed the problem, right? You see a theme here? All these solutions have not even come close to addressing what the problem really is, that the soil that the house is sitting on can't support the weight of that house, right? And that's very common. You're not alone, right? And so what do we do about it? How do we overcome that problem and not rely on the soil that has not been able to support your house? Let's talk about our solution. Let me find real quick. I got a great video here to talk about the system that we're going to use to support your house here. This is one of our engineers, and so he does a great job. Let's take a look at it. Oop, hold on, fat fingered it. All right, here we go. Enjoy. Get your popcorn out.
When your home starts making popping noises, cracks develop, and doors and windows stop operating properly, it can be scary, leaving you worried and wondering how to fix it. The problem is the active, unstable soil that supports your home. Many homes were built on soil that was not properly compacted at the time of construction. As this soil compacts and collapses, your home drops as well. Another major issue is the moisture content in the soil. When the soil becomes overly dry, it contracts and shrinks, creating voids. When the soil is saturated, it washes away or becomes too soft and can't support the weight of your home. To permanently stabilize your home, you must go beyond these active unstable soils to bedrock, or what our engineers call load-bearing strata. The settle-stop push-pier system is the answer. The system utilizes steel piers to support the home on strong soils deep below the surface. Here's how it works. First, some soil is skillfully removed to expose the footing. A heavy-duty steel bracket is then secured to the cleaned and prepared footing. The push piers are then driven through the bracket deep into the earth. The weight of your home is then transferred through the piers into competent soils to prevent future settlement of your home. And not only will your home be permanently stabilized, there's also an opportunity to lift it back to its original position. So the piers rest on load-bearing strata, and the home rests on the piers. It no longer...
Oop. Does that make sense? I just wanted to stop it there because that's the critical part. That's what we're doing, right? Any other solution is just replacing your problem with the same problem, right? And so we've overcome that problem by supporting your house by the strongest thing on the planet, right? Okay. So we can go again here.
Is your home vulnerable to ever-changing soil conditions? It is now permanently stabilized. And to ensure your peace of mind, we back it with a fully transferable lifetime warranty.
Okay, awesome. So yeah, lifetime warranty, right? We stand by our work. And I know that we talked about doing it from the inside, right? And so I want to show you a quick graphic of what that looks like so you know what to experience and you know what the finished product's going to look like too, right? So it's very invasive doing it from the outside, and that's why I'm suggesting and we do it from the inside. We have the capacity for the style of basement that you have to do it, and it's just as effective, and it's a little more affordable, and it's a lot quicker, so we can get it done a lot faster. So let's go through this and I'll kind of describe what's going on. So first, the crew will locate all the locations that the piers are going to go in, and they chip away the slab so we have access to the exterior foundation from underneath, because our bracket's going to be inserted underneath the exterior foundation. We're going to use the weight of your foundation to drive in these piers. We first put in a starter tube that has an external sleeve, all right, and then we mount our equipment to use hydraulics to drive in those piers, right? And so we continue to add piers. We're measuring the pressure, because pressure will tell us how we're doing. It's not as important as to how far we're going, but how much pressure we have that we're going to be working against the bottom side of your house, right? And how stable it's going to be. And so we continue on, and then we put on our cap. We fasten the cap. And then in every location, you're going to see that we put in other smaller hydraulics, tie them all together, and then if it's mechanically safe and possible, we will lift them all together to see if we can achieve lift to get you as close as we can back to where you originally started, okay? Does that make sense? I hope so, because we have a solution that's going to absolutely work for you and achieve the results that you need, and you won't ever have to worry about having this problem ever again. How do you feel about the other solutions that I told you? They don't seem like they would work very well. You're right, yeah, and or we would be doing them, right? What we've been doing this for a very long time. Do you think this is the kind of project that you'd want to do on your home, so that way you would never have to worry about this problem again? Excellent, I agree.